Today we are going to learn gas dynamics. It is also called compressible fluid flow, and these are the list of topic we are going to learn one by one. The first one is introduction, in which we will see what is the difference between incompressible flow and compressible flow. We will also learn what is compressibility. Secondly, we will derive the governing equations which will govern how the properties of compressible fluid are going to change. There are three governing equations. The first one is continuity equation, or we can say mass conservation equation. The second equation is momentum equation, which is nothing but Newton's second law of motion. And the third one is energy equation, which is the first law of thermodynamics. After that, we will derive speed of sound. We will denote speed of sound by small letter a, and then we will define what is Mach number. We will denote it by capital M. Then we will move on to the next topic, which is one dimensional fluid flow. And in one dimensional fluid flow, the duct area A will be constant at 1 and at 2. This is our control volume inside the duct. At position 1, the fluid is entering at the speed of u1, and its property are p1, t1, rho 1, e1. Something is happening between point 1 and point 2, and that something is changing the property of the fluid from 1 to the property at point 2. And then something can be normal shock wave, or the flow with heat addition, which is called Rayleigh flow, and the flow with friction, which is also called Fano flow. We will see all these three phenomena in detail. Then we will move on to what is called quasi one dimensional flow, in which our area A is a function of x direction. It is called quasi one dimensional flow because properties such as pressure, density, temperature are function of x only, are function of x only. They are constant in y and z direction. Such type of flow occurs in nozzle and diffuser. Now let us talk about application of gas dynamics. And these are the list, though it is not exhausted, but few applications of gas dynamics. The first one is jet propulsion engines. So this is the example of a jet propulsion engine. And in jet propulsion engines, the air first enters into a compressor. This is a compressor. Then it goes into a combustion chamber where the fuel and air combustion happens, and in the end this is our nozzle, or it is a exhaust from where jet propulsion engine get the required thrust. All jet propulsion engines are designed for a particular Mach number at the exit, for a particular Mach number at the exit, and its design depends on these conditions. The second example is of rocket engine. Rocket engines are similar to jet propulsion engine, except that in rocket engines the oxidizer is stored inside the engine. Next application is supersonic missiles. For example, BrahMos. India and Russia together have designed BrahMos supersonic missile. Another application is if we have to transport natural gas in gas pipelines. You all know about Tapi natural gas pipeline from Turkmenistan to Afghanistan, Pakistan, and lastly India. So natural gas will be extracted in Turkmenistan, then it will be transported through Afghanistan and Pakistan to India. And we all know that natural gas is a compressible gas. And particularly, we will apply Fano flow equations to this problem of natural gas transportation. Another application is supersonic wind tunnel. So this is a supersonic wind tunnel. This is in one of the IITs. This one is particular in IIT Bombay. And these supersonic wind tunnels are for research purposes. These are for research purposes.